Okay, now we're getting a bigger crowd. I see Michael, I see Anthony, Irene. Welcome, everyone. Happy Friday. You made it to the end of the week. Okay, Kawsar, shall we wait for Diego or shall we get started? It's up to you.
I think we can start. I mean, he can join.
Okay. Yeah, I'm sure he'll join when he can.
Okay.
Okay, we'll get started then. So, good morning, everybody, and welcome to this very short and sweet edition of Trainee Talks. Trainee Talks is a series of research talks delivered by software engineering graduate students in the CREATE SE4AI program. And everyone in our program is receiving specialized training in the technical and social aspects of AI-based software systems. My name is Lori Akiyama. I'm the program coordinator for CREATE SE4AI here at Concordia University, and I'll be moderating the webinar today. So today, I'm very pleased to introduce our speaker, Kawsar. Kawsar is preparing to defend his master's thesis in 2 weeks, and he is a Master of Applied Science candidate in software engineering at Concordia University under the supervision of Professor Diego Costa. He's a member of the Realize Lab and, of course, a CREATE SE4AI trainee. Kawsar's research focuses on improving transparency in the software supply chain through software bill of materials, dependency analysis, and software supply chain security. Kawsar holds a Bachelor of Science degree in Computer Science and Engineering from the Islamic University of Technology in Dhaka, Bangladesh, and has worked as a software engineer at Therap. Today, Kawsar will be presenting his work on Beyond Compliance, a large-scale study on the completeness and consistency of the GitHub SBOMs. So as per our usual format, Kawsar will speak for 20 minutes, and then we'll open up the floor for a 10-minute Q&A. Just for everybody's information, this webinar is being recorded, and it will be available to view on our CREATE website at se4ai.org and also on our YouTube channel. So with that, I am pleased to turn things over to Kawsar for his presentation. Kawsar, please go ahead.
Thank you, Lori, for giving me the floor. So I'll begin. So as Lori has given an introduction of me, I'm Kawsar. I'm doing my master's in software engineering at Concordia under the supervision of Professor Diego Costa, and I hope to defend my thesis in a few weeks. So today I would like to present my work that is based mostly on SBOMs and GitHub SBOMs. So our work actually looks into the completeness and consistency of GitHub SBOM, and we also try to look into the comparison of GitHub SBOMs compared to other popular SBOM tools. So I know that this term might not be familiar with most of us, software bill of materials, so I'll just begin with an example. So for example, this is very hot in Montreal, so I want to I want to buy an ice cream from the store. So I can go to the store and ask for an ice cream, my favorite brand, my favorite flavor, and I can just start eating it. But if I'm actually conscious about my health, I should look into the ingredients list before I start buying the ice cream or before I start eating the ice cream, because I need to protect myself. I want to look into two specific things. At first, I have to look into if the ice cream contains any specific ingredient that I am allergic to, so that I don't get any harm. Also, there might be some dietary rules that I need to follow, like I can only take vegan food or I can take only halal food. So I have to think about my health and safety and also the dietary rules. Now, when I'm using a software, I'm using software, I need to think about in that perspective also, because software also works the same way. Software comes as like a black box or a package, but it doesn't have any labels on it. So why do we care about that? Because modern software is mostly assembled using third-party libraries, not written from scratch. Whenever we use a software, we actually use third-party libraries, we use other people's which we didn't write. For example, if we look into a simple application, it can have React, Lodash, Axios, the popular libraries, and also these libraries can come up with their own set of transitive libraries. So whenever we are using those third-party libraries, it is actually accelerating the development velocity. It is cutting the cost, but it is coming up with the risks and vulnerabilities that those libraries contain. And for any moderate to large size application, the dependency networks can span thousands of interrelated packages. So how does SBOM come into that picture? So SBOM, for a layman term, actually works as the ingredients label for software. Or if I want to make it more formal, it is a structured inventory of the components that make up a software system, including the versions, the licenses, and the dependency relationships. Just like I want to look into the ingredients list of an ice cream or a food item, I need to look into the component inventory of the software. Just like I need to ask the question whether my food contains peanuts, which I'm allergic to, I also need to ask the question whether my software contains any known vulnerabilities. Just like I need to look into whether my food is not compliant with vegan or halal restrictions, I should also ask the question whether the software components that make up my software has license compatibility. So here is an example of a real GitHub generated SBOM. So we can look here that for this SBOM, this software has a list of packages. So it uses the popular Rails library. It also lists its version and its license. Also, it has a relationships array that describes how this software repository depends on this software package. So here I've just shown a simple software that is containing only one package, but it can contain thousands of packages, as we have mentioned before. So why now we are caring about SBOMs? Because SBOMs are not only confined to best practices anymore. US government came up with a federal mandate that whenever you are procuring software for the federal software procurement, you have to provide an SBOM. And National Telecommunication and Information Organization Authorization came up with a committee that set up some minimum baseline elements that each SBOM must contain. So SBOM is being adopted into the industry because it is a requirement, and also whenever you are providing an SBOM, it ensures that your software is free from security vulnerabilities, and it has some quality, because whenever you are listing the components in front of the consumer, you will always have the tendency to make sure that you don't have any component that has any vulnerability. So why do we want to look into GitHub? Well, the easiest answer is GitHub is the largest inventory of open source software. GitHub hosts millions of software repos that are open source. And GitHub provides the ability to build a dependency graph from the manifest log files. Whenever we use GitHub dependency graph for a software repository, we can just export an SBOM from it using the UI or the REST API. And also, when doesn't matter how many people are working in my team, doesn't matter how many updates I make to a repository, I can always generate a new SBOM, and it can always stay synchronized with the repo's current dependencies. And also, I don't need to worry about whether the repository contains JavaScript code, Python code, Rust code, or dependency network that I'm not very familiar with. The GitHub uses only one single common approach, and it applies to the very different ecosystems, and it will always generate an SBOM for me, doesn't matter which language the repository contains. But the question comes here, the generated SBOMs by GitHub, are they really compliant? Are they really trustable? And can the practitioners actually rely on them? So based on that, I want to present the primary research statement or motivation behind our research, that automatically generated SBOMs are valuable only if they provide complete, consistent, and actionable metadata. GitHub generates SBOMs with one common approach that is applicable to different ecosystems that declare and manage dependencies in very different ways. But we want to look into whether these SBOMs at scale are compliant, whether they are actually better performing than other SBOMs generated by other tools, and whether they're reliable for vulnerability tracking. And we will also investigate the ecosystem level factors if there is any deficiencies. So I present our three research questions. The first one is, how compliant and complete are GitHub SBOMs? And then, how consistent is the GitHub SBOM tool compared to other SBOM generators? And then, how useful is the GitHub SBOM tool for vulnerability tracking compared to other tools? So at first, I'll go into the data set. How did we create the data set? And also, how do we extracted the SBOMs? So at first, we looked into GitHub. We chose the 10 most popular languages, and we added the threshold that the each repository must have at least 5 contributors so that we are not dealing with toy or hobby projects, and it should have at least 1 comment in the last 2 years so that the development cycle is active. And then we sort it by star count to use it as a proxy for popularity, and then we sampled 10,000 projects, 1,000 per language. Then we used GitHub SBOM tool along with 3 other most popular SBOM tools, Swift, Trivy, and Microsoft SBOM tool. These 3 are widely adopted in the industry and very popular among the practitioners. Then for each of the tools, we tried to generate 10,000 SBOMs. For some of the tools like Microsoft SBOM tool or Trivy, we encountered some failures, so we had to report them that we could not generate all of the SBOMs for those tools. So 10,000 repositories, 10 languages, 4 SBOM tools. This is our dataset. Now I would dive into the details of our methodology with each research question and also provide the finding for each research question. So the first research question is, how compliant and complete are GitHub SBOM? So as for the compliance, we are actually checking against the NTIA minimum compliance. I want to give some background about the NTIA minimum compliance. What does NTIA wants from a compliant SBOM? So NTIA says that whenever you are providing an SBOM, for each of the component of that software, you should provide the supplier of that component. You should provide the component name of that component. You should provide the version of that component. You should provide a unique identifier so that unambiguously you can refer to that component. You should provide the dependency relationship among the different dependencies that are listed in the SBOM. You should provide the author of the SBOM. So in this case, it would be the tool itself, and also the time step so that we can know at which point the SBOM was generated. So the NTS rules are very strict. Even if one single element is missing from your SBOM, the SBOM will be not compliant. So it is kind of all or nothing situation. Now I want to discuss how we approached our RQ1. So for the RQ1, for each of the SBOM generated by GitHub SBOM, we parsed it and scored against 3 completeness criteria. Then we aggregated by programming language. So at first, we looked into the NTIA compliance. For each of the SBOM, we checked the 7 NTIA minimum elements via the SPDX fields like name, version, supplier, unique ID, and so on. And then we checked that if the SBOM is compliant only when every element is present. Then we looked into the version coverage. We extracted the version info from each of the component, and we traced the dependencies, primary dependencies, also the transitive dependencies, and we compared the version presence from top level and the transitive. So we determined whether a dependency is transitive or top level by checking the relationship array. Then we also looked into the license availability. We checked the license concluded or license declared field. And we also again looked into the difference between the top level and the transitive dependencies. Then we average per project percentages and present them. So we found out that for each of the SBOM, for each of the component, GitHub provides the name always. It also always provides a unique ID that is part or package uniform resource locator. It also always provides the dependency relationship. It also always provides the author and time step of the SBOM. The version is language dependent. For some languages, GitHub provides more than 90% of the time provides the version. For some languages, the coverage is low. But the concerning thing is, for none of the SBOM, for none of the component, GitHub provided the supplier name. So because of missing only this field, 0% of all 10,000 GitHub SBOMs are fully NTI compliant. Now we look into how the version coverage differs in the SBOMs in terms of dependencies, in terms of top-level dependencies and transitive dependencies. We can see that for most of the languages, more than 90% of the cases, the version is provided by GitHub SBOM tool. Go, Rust, and Swift almost provides 100% of the versions for all of the cases. There are 2 specific languages where we see a very deep in the performance, that is Java and Python. And if you look at the top level dependencies, the version coverage average is almost similar to all dependencies if we think. Now, if we think about the transitive dependencies, the 100% actually shows that whenever there is a transitive dependency present in a repository, GitHub always provides the version. But this is actually somewhat problematic because we looked into the depth and we found out that GitHub only lists the transitive dependency when the parent dependency. So if the parent dependency doesn't have a version, the transitive dependency is not reported at all. So the version is not mentioned at all. So the version is also only mentioned for those transitive dependencies which have parent dependencies that have version. Then we look into the license coverage and we find out that it varies more significantly than the version coverage. And license coverage is heavily polarized. We have found projects that cluster at 0% or 100%. For many of the programming languages like C, C++, Go, Python, Swift, for most of the projects, the license is reported at 0%. That means no list dependency was mentioned with the license. JavaScript and Rust do substantially better, and this is also supported by previous research where we saw that NPM and Rust package managers actually provide licenses for most of the dependencies than other ecosystems. And across all the ecosystems, less than 25% of the projects list licenses for every dependency. Then we look into our second research question, that is how consistent is the GitHub SBOM tool compared to other SBOM generators. So as we previously mentioned, we selected Trivy, Sift, and Microsoft, three other most popular SBOM generation tools. So for RQ2's approach, for every selected repository, we compare SBOMs from GitHub with the three other tools at two levels. How many dependencies each tool detects and how complete the metadata for those dependencies is. So at first, we count the components. For every SBOM, we count the total number of components each tool reports for the repository. Then we look into the differences because we show that the distribution is heavily skewed. So we do two statistical analysis. The first one is Kruskal-Wallis H-test per language. So to check, do the four tools counts differ significantly? And if so, then we do Dune's post-hoc comparison for pairwise comparison between GitHub and each tool. Then we look into the metadata. So we look into the value, look into the version and license information. So the version is present if the version info is not empty or not marked as unknown or any garbage value. License is present if license is declared and it also doesn't have any garbage value like no assertion, none, or unknown. Then for each of the language, we do the per repo aggregation by doing the average, and then we present the results. So if we look into the component detection, just by looking into the distribution, you can see that there is significant difference among the languages and among the tools. So we did the Kruskal-Wallis H-test, and we found that the p-value is less than 0.05 for 9 out of 10 languages. That means the counts vary significantly for 9 of the languages. Only Go is the exception, where we found that p-value is 0.186. So as the difference was significant for 9 languages, we did the post-hoc analysis with Dune's test, and we found out that GitHub SBOM tool diverges from, let's say, Microsoft SBOM tool in 9 of the languages, for Sift in 7 languages, and from TV in 8 languages. So the similarity is very low, and each of the tool is reporting different component counts for each of the language. Then we look into the version and license coverage. So we found out that Microsoft SBOM tool actually leads in version coverage. It almost always presents the version whenever it's listed dependency, except for Swift, or it lags slightly at 99.8%. And Microsoft and GitHub SBOM tool actually matches it in almost all of the ecosystems, but it lags significantly in Java and Python, those two languages that we mentioned previously as well. But if we look into the license ability, the percentage of components that have a license reported by the SBOM tool, we find that GitHub actually does a better job than each of the tool. GitHub leads in license coverage in 9 of the 10 languages. Now we move into the practical usage of the GitHub SBOM. So this is our third research question, where we look into how useful is the GitHub SBOM tool for vulnerability tracking compared to other tools. So for vulnerability tracking, we have to at first identify which components are reported by the SBOM, because if I don't know about the component, how can I look into whether it is vulnerable or not? So that's why we choose package uniform resource locator as the identification of the component, because it gives a canonical ecosystem agnostic way to match components to known vulnerabilities. It gives me a uniform way so that I can identify a component, then I can use that identification to find out if that component is vulnerable or not. So to find out the vulnerabilities, we chose osv.dev, open source inventory, where any open source component can be reported with its vulnerabilities, and it is maintained and very popular among the practitioners and the researchers. So at first, we want to extract the pearls from each of the SBOM's listed components. So we look into the external refs on every component, external refs field on every component, and we see if the reference value is type is Perl. If the type is Perl, then we extract the value. Then we batch query to osv.dev API. So we submit all of the Perls from one SBOM together to the osv.dev to find out all of the vulnerabilities associated with that software. Then we aggregate the results. We collect every vulnerability from osv.dev results for that SBOM's components, and we aggregate the results. And then we do the comparison across the tools. We again do the Kruskal-Wallis tool for Kruskal-Wallis test for the comparison among the four tools, and then we do the post-hoc analysis with Dunes test for vulnerability counts, so on pairwise basis. And we find out that whenever we are looking into Perl extraction, GitHub always provides Perl for every single dependency. So whenever GitHub SBOM tool reports a component in any SBOM in any language, it always provides a Perl so it can be uniquely identified. Microsoft SBOM tool almost mirrors it only apart from Swift, but for the other two tools, Swift and Trivy, the performance varies significantly. So as GitHub SBOM tool provides Perl for every single component, so it is possible to find out which vulnerabilities are associated with a software component in every single case, because we know for sure which component is associated with my software, and I can uniquely identify that component. So if I know the Perl, I can uniquely search on osv.dev which vulnerabilities are associated with that component. So with that, we can see that for almost all of the languages, GitHub actually reports more vulnerability counts than the other languages. And we also confirmed it when we checked into the distribution, and we found out that GitHub provides more vulnerability counts than all of the other tools. Now, here's the problem. The problem here is that whenever whenever a version of a component is mentioned in the SBOM, the Perl also contains the version. But if the version is not mentioned in the SBOM, or the version has a range or a same word syntax, then the Perl does not have any version. So if I have a Perl that has the version and I query to sv.dev, I would exactly get those vulnerabilities that are associated with with that exact version of that library. But if I query without the version, I will get a list of vulnerabilities. All of those are related to that library, irrespective of the version. So it is a problem for the practitioner, because whenever they are using a software and that has a component that might be using a later version, and that is not, and those vulnerabilities are not relevant. So here we can see that for if I query with 77.0.3 version of setup tools, I get two vulnerabilities, and I'm sure that my software is using these libraries 77.0.3 version. So these two vulnerabilities are actually I should care about. But if I query without the version, I would get 6 vulnerabilities, and I'm not sure which of these 6 I should care about, or are these 6 actually relevant or not. So as GitHub provides 100% of the time Perl, it is a good sign, but as it fails to provide version every time, so this is an actually upper bound of the vulnerabilities, not the 100% precision of the vulnerability detection. So far, we have looked into the completeness and the compliance and the inter-tool comparison. But whenever we looked into the presence of the version field or the license field, we only looked into whether that exists or not. But we did not look into whether the reported version or the reported license is actually accurate. So how do we want to see that if the reported version or the reported license is accurate? That's why we did analysis on a sample of our whole data set. We randomly sampled 600 repositories, 200 per language, which was Python, Java, and JavaScript. And for each of the repository, we cloned the repository at the same time when we generated the SBOM, and then we compared whether the repository has the exact version or the exact license that the SBOM is reporting. The SBOM might report a version, but the version might not be accurate. The SBOM might report a license, but the license might not be accurate. So how do we achieve that? So for dependency resolution for Python, we use pip install into a fresh virtual environment, and then we use the pip freeze so that it captures the fully resolved environment, including the transitive dependencies and each pin to an exact version. So even if the developer mentions a ranged version or a same word into the metadata or into the source code, if I do pip install and then followed by pip freeze, I have the exact version that my software will be using. And for the license ground truth, we queried the authoritative PyPy API, which is actually an authority for Python dependencies. So we can find out which exact license is related to which version, which library. For Java, the version resolution is actually simpler because we can use the Maven dependency tree, MVN dependency tree on each pom.xml file, which triggers the Maven's resolver to return the full transitive tree with concrete selected versions. So you know that in pom.xml, we are not bound to provide the version if the version can be fetched from a parent pom or if there is a dependency tree. But if we use Maven dependency tree resolution, we will always get the exact version, also including the transitive dependencies. And for the license ground truth, we had to use libraries.io API because we don't have an authoritative Maven central API like we have for Python. And for JavaScript resolution, this is the simplest because for JavaScript projects, in most of the cases, we have the package log.json or the yarn log file, which actually lists the exact version, exact pin version the software is using. So we don't need to even use any command to generate the exact version the software is using. But there's a catch. Sometimes the package.log or the yarn.log might not exist in the repository. So we excluded those repositories and we went to the next candidate, and that's how we created the 200 repository count for JavaScript. And for the license ground truth, we queried the authoritative npm registry API to find out the license. After we did all of this, we tried to match the license and the version reported by the repositories and the SBOM, and we did the component detection. We wanted to find out whether the SBOM actually detects the component correctly. Suppose the repository mentions React as a dependency that is being used in the software, but the SBOM misses it. So this is a mismatch. Or suppose the SBOM mentions that the repository uses NumPy, but actually the repository does not use NumPy. So this is again a mismatch. So we did the component detection and we did the precision recall on F1 via the normalized name matching. Then we looked into the version accuracy. For the fraction of true positives that we found that the SBOM and the repositories agree that these dependencies belong to this software, we looked into the version accuracy for those components. And similarly, we did it for the license accuracy. So if we look into the component detections, F1 score, and the version reporting accuracy and the license reporting accuracy, we can see that the tool that lists the most components is not necessarily the most accurate. So we saw previously that GitHub reports more component than any other tool. But if we look into the accuracy of the component detection, like the F1 score or the version accuracy, we find that Microsoft SBOM tool actually performs better than GitHub in terms of component detection and also version reporting accuracy for two languages. Only in JavaScript, GitHub holds the lead. And if we look into license reporting accuracy, no SBOM tool is doing a good, let's say, good job because no SBOM tool is providing near 95% or 99% accuracy
Oh,
for license.
sir. I hate to interrupt, but I'm just looking at the time, and
I'm
we
sorry.
need some time for questions. So just keep that in mind.
Yeah, sorry. Okay,
Yeah, no worries, no worries. Thanks.
Okay, so this is the thing that we have to look into, that just because a tool reports more components, it does not mean that it's most accurate. So then we looked into a root cause analysis across all 10 ecosystems, why the licenses are missing. So we found out that if component does not mention an exact version or the version is absent, like the version is mentioned without any exact version, like with a semver or a pin or a range version, the license is missing. Also, if the package manager is not supported by the SBOM tool, it can't actually provide the license. And for the why versions are missing, if we looked into specific patterns, we can find out that suppose sometimes in the metadata files you don't write the version exactly. Like for Python, you have the requirements.txt file that does not require you to mention the version. So if the environment does not require you to write the version, most of the developers don't write the version, and in those cases, the version is not mentioned and the SBOM tool is not able to fetch the version. So if we look into the feature threats and future work, we have to mention that one threat is that every tool must generate the SBOMs from the same snapshot of the repository. A repository might be updated 10 times in a single day. So we have to make sure that all of the SBOMs are generated at the same time. And we made it sure by generating all the SBOMs at the same time. Then another threat is that all of the claims that we have made about the repositories, the JavaScript repository, Python repository, and Java repository, all of the claims that we have made are actually looking into the most dominant language reported by GitHub. But that repository can have also some small portion of code from other language as well. So for future work, I think we should look into ground truth construction for more ecosystems. I know it's time consuming, it's challenging for other ecosystems like that don't have simpler dependency resolution like Python, Java, or JavaScript. But this is an avenue that we should look into, and we should also look into the hybrid multi-tool SBOM generation. One SBOM tool is good for one thing, another is good for another thing. Can we combine something, or can we use LLMs to find out the enrichment? And also, if we do generate SBOM on different snapshots of the time, can we do a longitudinal SBOM quality tracking? So if I summarize our contributions, so this is the first large-scale study comprising 10 languages and 10,000 repositories, and comparison of inter-tool comparison between 4-tool comparison. And this is the first study that actually tries to measure the practical usefulness of GitHub SBOM tool in terms of vulnerability tracking. And we also did the first time the root cause analysis in terms of why the metadata are missing at the package manager level. And we have also made our replication package public so that further research can be done. So this is the conclusion that GitHub SBOMs are a useful baseline, but it's not a complete complex solution. We should look into the lackings and think about how can we enrich the SBOMs. And if one single field is missing, it fails the entire compliance, but it is not something that we should be scared of, because this is a binary thing, but we should look into the other positive things that GitHub SBOM tool has. And also, no single tool dominates every metadata dimension, and SBOM quality is also shaped by ecosystem conventions as much as tooling. If the developer is not mentioning the version, the SBOM tool is failing. So it is also responsibility of the developers to be more cautious when they are reporting the versions or the licenses in the repository. So thank you for listening to me. I have really gone over the time, but I would really like to welcome any questions that anyone has.
Thank you very much, Kawsar. Very nice talk. We do have time for a few quick questions. So Jasmine, please go ahead.
Thank you, Kawsar, for your really interesting talk. This is a topic of big interest for me. One result that really surprised me was about the semantic versioning. When you said that if you include semantic versioning in how you declare dependencies, the vulnerabilities that are reported in your SBOM might not be relevant, right? So semantic versioning is kind of a best practice if we wanted dependency management, or at least it's heavily used. But it kind of goes against it seems, the standards of SBOM. So how do you think, what do you think is the future of that? How can we make both work?
Well, so semantic versioning is a standard practice from the developer's perspective. Whenever the developer is mentioning the version in the metadata, they should use semantic versioning whenever it's possible. But the SBOM should report an authoritative version, that which version is being used at that exact time. So suppose it mentions tilde 77.0.3. That means that every version up till that version. So it should, the SBOM should report the latest version, not the other versions. And also SBOM shouldn't provide the range. And also, suppose the developer does not mention the version at all, the SBOM should look into the repository, the package repository like PyPy, and see which is the latest version that would be installed at that moment. So if the SBOM provides the latest version, it won't hamper from the developer's best practices.
So it really seems that SBOMs are inheriting the problems of like dependency management in different ecosystems, right? Because even the package log, for example, a lot of the times they're not present, and a lot of the times, however you generate that is gonna be different, right? From project to project or from tool to tool, whatever you use. So what do you think is the future of SBOMs in our case? I think SBOMs they're very important and they're like the future of dependency management, but I don't see a standardization happening anytime soon.
So from my personal indication that I have after looking into it, I think if we want to include more information into the SBOM, that can help. Like we only have a single version info field that actually provides the information that okay, this is the version that the software is going to use. But if we can include more fields into the SPDX syntax, that okay, this also how the version was resolved. Was it done by dependency tree resolution, or was it done by looking into the package registry? That can provide more information and that can help. So currently SPDX3 is being formulated, and also people are looking into the AI bomb field. So similarly, only the traditional software development perspective, if we think about these issues, we probably can propose more fields to be included, so the consumer has more information.
Thank you.
Thank you.
Thank you, Jasmine. Does anyone else have any questions for Kawsar before we wrap it up?
So maybe just a quick question, Kawsar. So thanks for the presentation. In your first RQ, for example, right, you showed that 0% were compliant and ITA compliant. So for me, and obviously it was mainly because they don't mention the source, right? So for me, that's the question I have for you. Is that a problem with SBOMs, or is that a problem with, or is that a real problem sort of with people not reporting? Because if nobody's reporting, maybe what you're asking is a bit impossible or not achievable.
Oh, well, so if I looked into the GitHub repositories for a sample of projects, and I found out that if the repository is actually coming from a reputable source like Google, if I look into the Guava library, so Guava library is generated by Google. So in that case, the SBOM should provide Google as the supplier. Or if we think about React is provided by Meta, so it should include Meta as the supplier. But many of the software libraries published on GitHub does not have any information about the author. So what should the SBOM do in that case? So that remains an open question, that the SBOM is not including the supplier because it can't find a uniform solution, or is it just lacking of the tool itself?
Yeah, thanks. I think that's kind of my point, right? My point is maybe if nobody's reporting it, maybe then it's not needed. But anyway, thanks for the answer.
Thank you.
All right. I think we're going to have to wrap things up there. But thank you so much, Kawsar, for your very nice talk. I really enjoyed your work, and I think you did a great job of synthesizing your research and communicating it very well. So I wish you all the best in your thesis defense. And thank you to everybody for joining. I hope you have a nice weekend, and see you again soon.
Thank you, Rory. Thanks to everyone.
Thanks. Thank you all. Have a good
Thank
weekend.
you.
Have a nice weekend. Thank you.
Thank you.
Bye.